Welcome to Unacademy. Let us crack GATE ME. Let us crack GATE CE. Unacademy is congratulating GATE 2023 top rankers. Let us crack GATE XE with the top indicators including AIR1. Crack GATE XE with best course repository. Use code KUR75. Flat 25% off on Unacademy GATE and ESE subscriptions. Offer valid till 17th June. Batches starts from 16th June. Foundation batch, one batch for GATE, ESE and PSUs in mechanical, and batch commences from June 16th. List of books home delivered within 15 days for iconic subscriptions. Unacademy Center for GATE. New offline batch starts on June 19th. For more information, contact 8585 Flat 25% off. And 3 months extension. Offer valid till 17th June. Offer valid till 17th June. Welcome to the Foundation Engineering Mathematics. Today our discussion is on probability and statistics. 2 points are selected. 2 points are selected randomly in an interval 0 to 1. Determine the probability that the sum of their squares is less than 1. 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 Let x be a random variable which takes values in the interval 0 to 1. Let y be a random variable which takes values in the interval 0 to 1. Now we have to find out the probability that sum of their squares is less than 1. Sum of their squares is less than 1 means x square plus y square less than 1. Now x varies from 0 to 1, y varies from 0 to 1 means it represents a square. This is a circle, part of the circle. X square plus y square equal to 1. x square plus y square less than 1 means this part. So now the required probability is favorable area by area of the sample space. That is pi into 1 square is area of the circle. It is only 1/4 of the circle by total area of the square 1 into 1, because x varies from 0 to 1, y varies from 0 to 1, complete square. So area of the square is 1 square unit and area of the favorable region is pi by 4. Therefore final answer is pi by 4. So correct answer is pi by 4. Next problem. Consider a biased coin. A biased coin comes up heads with probability 1 by 3, tails with probability 2 by 3. If a coin is tossed 2n times, the probability that sometime during this experiment 2 consecutive coin flips come up both the heads and both the tails. Both the heads and both the tails. We have to get probability that 2 consecutive heads come up with both the heads and both the tails. First you calculate contrary way, not getting both the heads and not getting both the tails. So probability that we never get consecutive heads or consecutive tails. That is head tail like that, or probability that tail head like that. Now chance of getting head 1 by 3, tail is 2 by 3, 1 by 3 n times, 2 by 3 n times. In this case here 2 by 3 n times and 1 by 3 n times, because total number of tails are 2n. Now this is nothing but 2 times of 1 by 3 whole power n and 2 by 3 whole power n. That is 2 power n plus 1 by 3 power 2n. So now the required probability is not getting The required probability is we have to get both the heads and both the tails consecutively. To get consecutively both the heads and both the tails, we have to subtract this probability from 1. So the required probability is 1 minus 2 power n plus 1 by 3 power 2n. That is 3 power 2n minus 2 power n plus 1 by 3 power 2n. Next problem. 3 integers are selected at random from 1 to 20. What is the probability that their product is even? Their product is even. Their product is even. Observe. 3 integers are selected at random from 1 to 20. If you want to get the product is even number, if at least one number is even, the product is automatically even. Understood? That's why probability that the product of 3 numbers is even is nothing but probability that at least one of the number is even. If one of the number is even, that is nothing but 1 minus probability of none of them is even. None of them is even. 1 minus none of them is even. Total 20 numbers, you are going to select 20C3. In that 10 even numbers, so 10 odd numbers, so 10C3 by 20C3. None of them is even. That is 1 minus 2 by 19. 1 minus 2 by 19, that is nothing but 17 by 19. 17 by 19 is the required probability. Next problem. If A and B are two events such that the conditional probability that probability of A by B equal to 1, then probability of B complement by A complement is, probability of B complement by A complement is Now, observe. Probability of A by B equal to 1. Therefore, probability of A intersection B by probability of B equal to 1. Therefore, probability of A intersection B equal to probability of B. Next, probability of B complement by A complement equal to probability of B complement intersection A complement by probability of A complement. 1 minus probability of A union B by 1 minus probability of A, 1 minus P of A plus P of B minus P of A intersection B by 1 minus P of A. That is nothing but, since P of B equal to P of A intersection B, therefore P of B equal to P of A intersection B means this result equal to 0. Therefore 1 minus P of A by 1 minus P of A, after cancellation result is 1. Therefore answer is 1. Next, the probability that a person will get electrical contract is 2 by 5 and he will not get plumbing contract is 4 by 7. The probability that at least one contract is 2 by 3. The probability that the person will get both the contracts. The person will get both the contracts. The person will get both the contracts is observe here, probability that a person will get electrical contract is 2 by 5. Probability of not getting plumbing contract is 4 by 7. Probability of getting plumbing contract is 3 by 7. Now, probability of getting at least one contract is 2 by 3. either plumbing or electrical is 2 by 3. Now, probability of getting both the contracts. Observe here, P of EL plus P of PL minus P of PL intersection EL equal to 2 by 3. This is 2 by 5 plus 3 by 7 minus PL intersection EL is 2 by 3. Therefore, probability of PL intersection EL is 2 by 5 plus 3 by 7 minus 2 by 3. Now, LCM 105, 42, 45 minus 70. 5 plus 2, 7. 87 minus 70. That is 17 by 105. 17 by 105. An integer is selected from set 1, 2, 3 and so on 100. Let A be the event that this is divisible by 3. B be the event that this is divisible by 7. Consider two statements, S1 and S2. S1 is both are mutually exclusive, S2 is both are independent. Now which one is correct? Now which one is correct? Whether both are independent or both are mutually exclusive, or one is correct, another one is incorrect, or both are incorrect. Observe, a number is selected at random from 1 to 100. What is the chance that it is divisible by 3? That is event A. Probability that a number is selected at random, it is divisible by 3, 33 by 100. The number is divisible by 7. The number is divisible by 7, that is 14 by 100. The number is divisible by both. 4 by 100. Now, probability of A intersection B is non-zero. Therefore, A and B are not mutually exclusive. Not mutually exclusive. Now, probability of A into probability of B is 33 by 100 into 14 by 100, which is not equal to 4 by 100. Therefore, probability of A intersection B not equal to probability of A into probability of B. Therefore, A and B are not independent. A and B are not independent. Therefore, neither mutually exclusive nor independent. Last option is correct. Suppose we want to pick up two members from 1 to 100 randomly. What is the probability that the sum of the two numbers is divisible by 5? Sum is divisible by 5. Observe here. If you select two members from 1 to 100, those numbers could be in the form of 5, 5q, 5, 10, 15 like that, or 5q minus 1, 5q plus 1, or 5q minus 2, or 5q plus 2. Now, the sum of the two numbers is divisible by 5. Sum of the two numbers is divisible by 5 means total 100 numbers. You are going to select 2. So, denominator is 100 C2. Now, sum of those two numbers divisible by 5 means either you have to select both the numbers from coefficient of 5. That means 20 C2, or one number is from 5q minus 1, another number is from 5q plus 1. If you add both, you will get the number is divisible by 5. So, sum is divisible by 5. So, 20C1 into 20C1 plus one number is from 5q minus 2 and another number is from 5q plus 2. So, 20C1 into 20C1. If you simplify this, you will get 0.2. 1 by 5, that is nothing but 0.2 after simplification. Next problem. In a housing society, half of the families are single child families, remaining half are two children families. If a child is picked up at random, that child has a sibling. Suppose there are 100 families. 50 families are one child families, 50 families are two children families. Total, how many children are there? 150 children are there. From this 150, if you select one child at random, from 150, one child is picked up at random, what is the probability that the child has a sibling? So, favorable cases are 100 C1. 52 ja, 53 ja. 2 by 3 is the required probability. Next one. A random variable x denotes the outcome of throwing a fair dice. Outcome of throwing a fair dice. The variance of x is. What is the variance of x? X be a random variable, outcome of throwing a fair dice. What is variance of x? If one dice is thrown, the possible outcomes are 1, 2, 3, 4, 5, 6. Now, expectation of x is sigma x into p of x, 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6, 4 into 1 by 6, 5 into 1 by 6 plus 6 into 1 by 6. 1 by 6 of 1 plus 2 plus 3 plus 4 plus 5 plus 6. 21 by 6. 3.5 or 7 by 2. Expectation of x is 7 by 2. One square into 1 by 6, 2 square into 1 by 6, 3 square into 1 by 6, 4 square into 1 by 6, 5 square into 1 by 6, 6 square into 1 by 6. 1 by 6 of 1 plus 4 plus 9 plus 16 plus 25 plus 36. 14 plus 16, 30. 30 plus 25, 55. 55 plus 30, 85. 85 plus 6, 91 by 6. 91 by 6. Now we have to calculate variance. Expectation of x square minus expectation of x whole square. 91 by 6 minus 7 by 2 whole square. $364 minus 294, 70, that is 35 by 12. Variance of x is 35 by 12. Next problem. A women's health clinic has 4 doctors. Each patient is assigned to one of them. If a patient gives birth between 8 a.m. to 4 p.m., then her chance of being attended by assigned doctor is 3 by 4. Otherwise, it is 1 by 4. What is the probability that the patient is attended by the assigned doctor when she gives birth? Observe here. She gives birth between 8 a.m. to 4 p.m. is 1 by 3. 4 p.m. to 8 a.m. is 2 by 3. Now, the case may be attended by assigned doctor or not assigned doctor. This case may be dealt by assigned doctor or not assigned doctor. Now, 8 to 4, the case is assigned, attended by assigned doctor is 3 by 4. Not assigned doctor is 1 by 4. Here assigned doctor is 3 by 4, not assigned doctor is 1 by 4. What is the probability that the case is attended by an assigned doctor? Now, you have to calculate 1/3 into 3 by 4 plus 4 p.m. to 8 a.m. 2 by 3 into, during that time also assigned doctor 3 by 4. Understood? 1 by 3 into 3 by 4 plus 1 minute. This is not 4 p.m. to 8 a.m. is not assigned doctor. So this is reverse. Four p.m. to 8 a.m. assigned doctor is not available. So chance of assigned doctor is 1 by 4. Not assigned doctor is 3 by 4. Reverse. Now 2 by 3 into 1 by 4. Now simplify this. 3 by 12 plus 2 by 12, that is 5 by 12. Because during this odd time, chance of assigned doctor is only 1 by 4. Not assigned doctor is 3 by 4. Next problem. Let x be a random variable having density function f of x equal to cx in the interval 0 to 2. Integral 0 to 2 cx dx is 1. Because it is density function. C equal to 1 by 2. Now probability of x greater than 1. Probability of x greater than 1 is 1 to infinite f of x dx. 1 to infinite f of x is cx dx. Integral 1 to infinite, the value of c is 1 by 2. Integral x dx is x square by 2 from 1 to infinite, not infinite, 1 to 2, because upper limit is 2 na. 1 to 2. That is 1 by 4 of 2 square is 4, 4 minus 0. That is 4 by 4. That is 1 minute. 1 by 2 is the value of c. So x square by 2. 1 by 4, 2 minus 1. 2 minus 1. 1 by 4, 2 square is 4 minus 1. That is 3 by 4 is the required probability. Next problem. Suppose a pair of 6-sided fairy dice are rolled. Let x and y be the numbers appearing on the dice. If z is modulus of x minus y, then expectation of z is first you have to prepare probability distribution table. Z and corresponding probability. Z value is a number appearing on the first die and number appearing on the second die. What is the difference? So 0, 1, 2, 3, 4, 5. 0. How many cases difference is 0? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 comes. 6 by 36. Difference is 1 in 10 cases. 1, 2, 2, 3, 3, 4, 5, 4, 5, 5, 6. Reverse way. That's why 10 cases. Next, difference is 2. In how many cases? 1, 3, 2, 4, 3, 5, 4, 6. 4 cases. Reverse way 4 cases. Total 8. Difference is 3. In 3 cases. 1, 4, 2, 5, 3, 6. Reverse way 3 cases. Total. Now difference is 4. 4 cases. Difference is 5. Only in 2 cases. Now we have to calculate expectation of Z. 0 into 6 by 36. 1 into 10 by 36. 2 into 8 by 36. 3 into 6 by 36. 4 into 4 by 36. 5 into 2 by 36. Simplify this. 70 by 36. 35 by 18 is the value of expectation of Z. 30 is the value of expectation of Z. Understood? A coin is tossed n times. Let x be a random variable that counts how many coins comes up heads. Let a be a constant. Then expectation of a power x is expectation of a power x is given by x equal to 0 to n a power x into ncx 1 by 2 whole power x 1 by 2 whole power n minus x. 1 by 2 whole power x into 1 by 2 whole power n minus x is 1 by 2 whole power n sigma x equal to 0 to n a power x into ncx. 1 by 2 whole power n when x equal to 0. Observe, when x equal to 0, a power 0 1 into nc 0, a power 1 a into nc 1, a square into nc 2, and so on. A power n into ncn. Understood? That is nothing but expansion of a plus 1 whole power n. Binomial expansion. Therefore, a plus 1 by 2 whole power n is the answer. A plus 1 by 2 whole power n is the answer. Expectation of 2 plus x whole square. Now, mean is 1, variance is 5. Expectation of x square minus expectation of x whole square is 5. Expectation of x square minus 1 square equal to 5. Expectation of x square is 5 plus 1, 6. Now we have to calculate expectation of 2 plus x whole square, 4 plus 4x plus x square. Expectation of 4 plus 4 into expectation of x plus expectation of x square. Expectation of 4 is 4. 4 into expectation of x is 1. Expectation of x square is 6. 4 plus 6. That is 14. Next one. Suppose that a random variable x has possible values 1, 2, 3 and so on n with the probability mass function k into 1 minus beta whole power x minus 1. Now, the value of constant k is now we have to calculate the value of constant k. A random variable x has possible values 1, 2, 3 and so on. P of probability mass function is provided. Then we have to calculate the value of k. sum of all probability mass functions equal to 1. Sigma k into 1 minus beta whole power x minus 1 equal to 1. K of, when x equal to 1, it will be 1 minus beta whole power 0. If x equal to 2, 1 minus beta whole power 1. If x equal to 3, 1 minus beta whole square and so on equal to 1. Now 1 plus r square plus and so on. 1 plus r square plus and so on is a by 1 minus r. Therefore k into 1 by 1 minus beta equal to 1. Therefore k by beta equal to 1. Therefore k equal to beta. The value of k is beta. Understood? The value of k is beta. Let x be a random variable with probability distribution. Then expectation of 2x plus 1 whole square. First you have to calculate e of x, then e of x whole square. E of x is minus 3 into 1 by 6. 6 into 1 by 2. 9 into 1 by 3. Minus 1 by 2 plus 6 by 2 is 3. 9 by 3 is also 3. 6 minus 1 by 2 is 11 by 2. Expectation of x is 11 by 2. Expectation of x square. 9 into 1 by 6. 36 into 1 by 2. 81 into 1 by 3. 9 by 6. 3 3 ja, 3 2 ja. 36 by 2 is 18. 81 by 3 is 27. 27 plus 18, 45. 45. 45 plus 3 by 2. plus 3 by 2. 45 to 90. 93 by 2. Now we have to calculate expectation of 2x plus 1 whole square. X whole square is 4x square. 1 plus 2 into 2x into 1. 4x. 4 into expectation of x square plus 1. 4 into expectation of x. Expectation of x square is 93 by 2. Expectation of x is 11 by 2. (93) into 2. 2 3 ja 6, 2 9 ja 18. Plus 1. 2 into 11, 22. 23 plus 186. So 209. Final answer is 209. Expectation of 2x plus 1 whole square is 209. Understood? Next problem. If you throw a fair dice, if an odd number turns up, you get that number of rupees. If even number turns up, you have to pay that number of rupees. what is the value of expectation in rupees for each throw? So you have to calculate expected gain or expected loss. Expected gain or expected loss. Now, x value 1, minus 2, 3, minus 4, plus 5, minus 6. Because if odd number comes, you have that number of rupees gain. If even number comes, that number of rupees loss. That's why. Now, chance of getting 1 by 6, 2 also 1 by 6, 3 also 1 by 6, 4 also 1 by 6, 5 also 1 by 6, 6 also 1 by 6. Corresponding probabilities. Now, expected value of x, 1 into 1 by 6, minus 2 into 1 by 6, plus 3 into 1 by 6, minus 4 into 1 by 6, plus 5 into 1 by 6, 6 into 1 by 6. If you take 1 by 6 common, 1 minus 2 plus 3 minus 4 plus 5 minus 6. 1 plus 3 plus 5, 9. One plus 3 plus 5 is 9. Minus 2 minus 4 minus 6. Minus 6 minus 6 minus 12. Finally, minus 3 by 6. Minus 1 by 2. So answer is 1 minus 1 by 2. So loss is minus 1 by 2 in this game. Understood? Loss is minus 1 by 2. I hope you understand. Thank you.